Okay, so let's talk about acids and bases. First of all, let's start with the definition of an acid. An acid is a solution that has an excess of hydrogen ions. This is going to give them a sour sort of taste. In fact, I believe hot peppers like jalapenos have a molecule called capazian. I think I'm pronouncing it right. And that releases the hydrogen ions that gives you that burn, the beyond the sour. When you add an acid to water, to H2O, you're going to get the H plus ions, hydrogen ions, plus the H2O is going to make the H3O ions. Those are called hydronium ions. That's actually what is giving acids their properties. The more excess hydrogen ions you have, the more acidic the solution. I've already mentioned that acids taste sour, and since we're in a science class, I do have to point out that you should never ever taste things to find out what they are. There are plenty of other things that you can do. That being said, there is a point where you gotta taste something. There's a whole industry of food science where they do this stuff, and then once they believe that it's safe, they'll go ahead and taste it and everything. There's a story of saccharin, I believe, the artificial sweetener. It's the one in the pink packets. It's the oldest one. Was discovered in the late 1800s, early 1900s by a guy who did chemistry as a hobby in his basement. And the story is that his wife called him up for lunch, so he went upstairs, started to eat his bologna sandwich, and it was really, really sweet. So he accidentally made something in the lab that tasted very sweet. So he ran downstairs and tasted everything in the lab until he found what it was. Luckily, he didn't die from tasting the wrong thing. But there's a few of those in history, but it's a big no-no now. Don't taste stuff to confirm that. But if something is sour, that is an acid. Acids will conduct electricity. They're used in batteries. They're corrosive. They can break down, skin, all sorts of things, really. And some of them are going to react really strongly with metals. It's kind of cool. There's this stuff called litmus paper. Litmus, I believe, is a fungus, and it changes color in the presence of an acid or base. So it'll actually turn litmus, the fungus, into red. And what they do is they'll take the fungus and I guess they dry it out and grind it up or whatever and incorporate it into paper, and that's called litmus paper. So you can pause this, take a look at the list here of some common ones. Next year in chemistry, when you're doing some of the stuff, some of the labs, you might use acetic acid. That would be a stronger concentration than vinegar, so think of the vinegar smell, but amplify it. Citric acid, that's used in a lot of candies and sodas and stuff like that. In fact, there was a popular candy, they were called Warheads, and I believe they were from the 90s, and people would pop it in their mouth and it would be so sour. I mean, a lot of people would spit it out. It was just too sour. And honestly, a lot of the candies today, the really sour ones, are about the same as those. So you're pretty used to those. But of course, science teachers had to geek out and kind of think about what was going on there, because it was sour to begin with, and then it was just normal candy afterwards. And one of the other science teachers said, "Oh, look, there's a powder on the outside of this." So because an acid is a solution, that powder that we're looking at was the solute. So the solvent in that case would be your saliva. So he figured, well, shoot, I'm just not going to let it become a solution. He stuck his tongue out and kind of blew, dried his tongue and put the warhead on his tongue, his dryish tongue, and looked at us and was like, I could do this all day. And so, it's kind of funny that he used a little science to make it so that he could outdo us, because we were seeing how long we could endure it and everything. And then somebody made him laugh, and we heard a poop sound. Looked over, and he had big eyes and closed mouth. He accidentally swallowed the entire thing. But anyway, ascorbic acid is vitamin C. This is something you can get from fruits and stuff, but you can also manufacture it. It's the exact same chemical, does the exact same thing. Sulfuric acid, it's used in fertilizers. That's the battery acid, like in your car battery. Not Duracell batteries. That's something different. I'll tell you about that. But we have lots of uses for acids. If you have heard of the show Breaking Bad or watched it, they've actually got a pretty intense scene where they use acid on the extreme. I don't want to give any total spoilers, but they use this stuff called hydrofluoric acid, and that's the one that will literally dissolve your bones. It gets into your bloodstream, and it was a crime movie, and they were trying to get rid of a body, and they found out. Okay, I won't spoil it, but they used it improperly and had some interesting results. But acids are a huge part of our modern life and our history, our technology, and everything that would depend on them quite a bit. So we have bases. A base, just like an acid, has an excess of ions, but these are hydroxide ions. That's the OH negative. An older word for base is alkali, and you can go buy alkaline batteries like the Duracells and Energizers. Those will conduct electricity, but they're a base. So whenever you leave the batteries in your in your Nintendo for too long, and you get those white crystals, I'll actually tell you what those are in a minute. That's actually from the base leaking out. Other thing is that bases can accept those hydrogen ions. So if I have the H plus the OH negative, that's just H2O. So if you put acids and bases together, you're going to get water. You'll get more stuff, I'll tell you about that. Bases are slippery, and there's a specific reason that's thoroughly disgusting and awesome. I'm going to tell you why. I'll do it on the next slide. Again, taste is not something you run around and do, but think of some food that has bitterness to it. That's usually a base. They're also corrosive. Your toilet bowl cleaner is a very, very strong base. You don't want to get on your skin. I mean, if you get on your skin, you rinse with a lot of water. But the interesting thing is, if you get cleaning stuff on your skin and you just wash it off in the sink and you're using soap, well, soap is a base. So you're actually not doing all that much. You just rinse with lots and lots of water. Even the acids is the best thing. These will conduct electricity. That's why they're used in the batteries. Now, this statement here is not great. It will some bases will react kind of violently with metal, but overall not so much. And they do the opposite with the litmus paper. They'll turn litmus paper blue. Now, I do not remember the details. I tried Googling it, and I can't find much, especially the details I was looking for, but I know our college professor mentioned this. In ancient Babylon, they found an interesting way of using litmus, the fungus. And what they would do is they would have a woman pee on the fungus, and it would change colors based on acidity, based on whether it was acid or base. And I cannot remember if it's supposed to be a base or acid or what, but if she's pregnant, then it'll turn a slightly different color. And this was like 3,000 or 5,000 years ago, was one of the first recorded pregnancy tests. And it's not that much different than what we use today. It's kind of I don't know if they do acids and bases. I'm not at all sure what they're detecting there, but I always like that one. It's pretty cool stuff. Soap, ammonia, all of these things, the corrosiveness to them, they make excellent cleaners. Now here's the fun part. These hydroxide ions are going to react strongly with grease. Grease is animal fat. Now, this is something you might have heard before, but there's a thing called Pioneer soap. This is soap that you can make basically from doing stuff with the ashes from your fire. And what you do is you set up a barrel and use straw for filtering, and you put your ashes in it, and then you pour, I think, hot water. And what it does is it helps strip out, I think it's lye, sodium hydroxide, out of the ashes, and then you make this mixture, and you get it like the right amount. So once you have the right strength of this lye mixture, the base, then you mix it with animal fat, pig fat, something like that. So really strong base and animal fat makes soap. Now if we think about it, go back to this slide here where I said that bases feel slippery. What's your skin made of? The outside layers don't really, you know how sometimes people like put a little pin through their, the outer layer of the skin, it doesn't hurt anything. The class I'm talking to is laughing because they were just talking about this last week, but that's dead fat cells on the outside of your skin. So if you're handling a strong base with your fingers, with your skin, it is literally making soap out of the outer layer of your skin, which is why it's slippery. Science is cool. Okay, I know that y'all have dealt with the pH scale before. It's just a measure of how acidic or basic it is. It goes from 0 to 14. Acids are below 7. Bases are above 7. 7 is neutral. And I'm sure that you've been through all these before, but this is what we use here in science. Notice that drain cleaner. That's that lye that I was telling you about that's used to make soap and stuff like that. What's interesting about the pH scale is it's a logarithmic scale. Now I'm sure you haven't done logarithms, but that just means that for every 1 unit, the actual increase is a factor of 10. So if I have something with a pH of 1, which is really acidic, and a second one, a pH of 2, which is less acidic, the pH of 1 is not twice as acidic, it's actually 10 times more. So if I have something that is a 5, and I move it down to a 4, which is more acidic, but then I move it down to a 3, I'm doing 10 times 10, so from a 5 to a 3 is 100 times more acidic. And that's just some fancy math called logarithms. You'll learn about that later. When you mix acids and bases, you get this unique reaction called neutralization. You're going to take your acid and your base, and you're going to mix them together, and you're going to get typically a neutral solution or more neutral. If they're perfectly equal, then yeah, you can neutralize it out and have absolutely nothing. You've heard of antacids, Tums. Tums is a base that's safe to eat. You eat that, swallow it, and it helps neutralize the acid in your stomach, causing fewer issues. One of the big exports in Georgia, typically South Georgia, is a mineral called kaolin. It's a white, chalky substance that is used in all sorts of things, including one brand name called kaopectate. It is a base, and it is a good, thing. I think whatever they use in Tums is a little better, but this kaopectate from kaolin is also pretty good. A neutralization reaction is adding an acid and a base and getting salt and water. Now when I say salt, I'm not talking about sodium chloride specifically. Salt is a general term for an ionic compound. These are all always double displacement reactions. So if I take a look, I've got hydrochloric acid, sodium hydroxide, this is my base, this is lye, this is nasty stuff. That's toilet bowl cleaner, or no, not even stronger than that. This is like Drano. So you get this on your skin and you'll be like, cool, slippery, and then moments later it burns because it's corroding your skin. And what happens is the hydrogen combines with the hydroxide to make HOH, and you're probably looking at that going, that's weird. It's H2O, it's water. And then the sodium and the chlorine combine to make salt. So in that case it was table salt. So yes, this, oops. So yes, this really nasty Drano and hydrochloric acid, you mix them and you get salt and water. Now if you have the equal amounts, you won't have any more leftover acid or base, and it would literally be just plain old salt water. In this one we have hydrochloric acid, and we have magnesium hydroxide. The hydrogen is going to combine with the OH negative to make water, and then the salt is going to be magnesium, the positive ion, the cation, and chloride, the negative ion. You'll end up with magnesium chloride. That's a type of salt. Here we have sulfuric acid. This is battery acid. This is a good chemistry limerick here. Little Willie was no more. What he thought was H2O was H2SO4. It looks just like water, and it's battery acid. You don't want to drink it. And here we have what I like to call nachos, but it's sodium bicarbonate. This is baking soda. So if you take sulfuric acid and baking soda, you'll end up with this hydrogen stripping one of the oxygens over there. We're not going to do anything when you have to predict this, so don't worry. And you get your water, but then you have sodium carbonate and then the sulfate, and as I'm looking at it, I'm going, it's been a while. I don't remember exactly which salt this forms, but you would have some sort of ionic compound over here. It would be sodium with carbonate and sulfate. I don't know what it's going to make, but it could end up being 3 compounds over here with the 2 compounds and the water, so 3 total. So every time you have an acid-base reaction, you're going to get some sort of salt and you're going to get water. And here's just a little list of salt, like sodium chloride is food flavor. You know what that is. Potassium iodide is actually what they put in salt to give you the iodine. We had, a long time ago, we had a lot of iodine deficiencies in the United States and around the world, where your thyroid, I believe, which is in your neck, maybe, I don't remember the details, would swell up and you have all sorts of problems. And they found that just adding potassium iodide, which is a lot like table salt, gives us the potassium that we need, or the iodine that we need in our bodies. Calcium chloride, potassium chloride. This potassium chloride, if you look at the periodic table, potassium and sodium are right on top of each other in the periodic table. So if you substitute some of the sodium for potassium instead, it tastes almost exactly like table salt. It cooks about the same and everything else. So pure potassium chloride is a great salt substitute, is what they like to say. It is a salt, because that's the chemistry term, but we like to call sodium chloride as the only salt when we're talking about English. So this just helps get rid of too much of the sodium in our bodies. A lot of them will just have a mixture of sodium chloride and potassium chloride. That just helps you reduce it. So all of these things are the products that we get when we're dealing with acids and bases.